All right, good afternoon, everyone. I'm Dan Lowe. This is Dustin Summers. We'll be presenting a live data-based approach to MVI. This is going to be a simplistic implementation of MVI using bare minimum libraries. Basically, you start Android Studio up, hit new project, and all these features are going to be available out of the box. So, brief introduction. I'm an Android engineer at Capital One. Been with Capital One for about a year. I've been in software engineering for about 6 years, and primarily focused in Android towards the latter half of that.
Yep, and my name is Dustin Summers, also an Android engineer at Capital One. Been a software developer for about 5-6 years, and not counting my GeoCities days, professional software development. Android for about the last three or 4 years.
GeoCities? Is that a JavaScript library? All right, so before we start to get into the weeds, let's knock out some high-level concepts. If you've seen some of the other talks today, some of these are going to be pretty familiar already. So what is MVI? MVI is Model View Intent. It's a reactive architectural pattern where the model is updated based on intents from the user or system, and the view is updated based on states emitted from the model. So then, what is the model? The model represents a single or multiple dynamic data structures. And then the view, of course, is the interface for displaying information to the user. But what is an intent? An intent is not an Android intent class, as some people might think, first off. It's actually more of an intention of something happening. So think of the user's intent when they interact with your application. That is the intent as we're talking about it here. So let's knock out some core concepts for MVI. MVI, we're going to be implementing a unidirectional data flow. This reduces edge cases and enforces single responsibility principle. It enforces, it doesn't guarantee it, right? So you could still write a blob of code in any given portion, but it really helps you break down and decompose your code into something that's more maintainable and testable. We're also going to be talking about a single immutable state. This is not that your state, your view can't change itself, but state changes have to be emitted from your model layer. And that helps us have a more predictable view for the user. As that view is currently being displayed, we're not worrying about anything else modifying that view, and we have a strict control of those view changes coming in. Then we have a single entry and exit point. So that's a big thing with this part of the presentation. You'll see that the model emits a state, which is consumed by the view, and the view emits an intent, which is consumed by the model. So this allows for consolidated points for validation, analytics collection, any kind of processing you might need to do on these objects going back and forth. But it simplifies the logic surface, makes things easier to test, breaks it down, and helps just make life easier. So this is a high-level overview of what MVI looks like. Pretty simply, the view emits an intent, the model consumes that intent, and emits a state back out to the view. Now, this doesn't have to happen in a particular order. So when you think about your model, you can have an intent that comes directly from the user, and most things are driven by the user, right? But say you have a delayed event that gets emitted from a server, and that event is then processed. Well, you might need to display something to your users. Think about a chat application where the chat message from the other user on the other end is not started by that user. So that's an intent coming from another angle. We'll be talking about intents coming from a straight user interaction with an application. So with that said, Dustin's going to demonstrate the application that we're going to be showing the code for in this demonstration.
Yeah, so here we go. Super, super simple. Single activity, single view. You can see up at the top we have a text field with current value displayed. We have an edit text field that will take input from our user, whatever number they want. And then we have an add button, which will add whatever that user input was to our current value and display that. And if the user decides not to enter a value and they just click the add button, you will see what toast message saying that you must enter a valid integer. And we will keep harping on this, but that is essentially an effect that you are showing to the user. It's a one-time occurrence. And one of the nice things about that is effects, again, it's just something that you only want to display once, so it will not survive your lifecycle change. So on rotation, you're not going to see that toast redisplay. So that's one thing about effects, and again, you'll hear us talking about that quite a bit throughout.
All right, so that's fine. But now let's talk about MVI as it applies to the Android architecture, because Android has some specific concerns. As Dustin just kind of mentioned here, is the life cycle. On these life cycle changes, we have to be worried about that, right? So let's start off talking about the model. And if you see the model here, you'll see on top of it, and not completely within the model, is the view model. And that's because the view model is not necessarily the model in our case. The view model kind of consolidates changes and listens for changes within the model and processes those so they can be emitted to the view via state. The state is then consumed by the view. In our presentation here, we're using our view is composed of an activity and an XML view. You can likewise use a fragment or another view, but we're specifically using XML views and using data binding here as a simplistic way to allow actions to be emitted from the XML. And then we have our intents being emitted from this. So let's jump into some of the key components that make this happen. State. So we're going to keep on talking about state. You might have heard it in other talks earlier today as well. But we're using, so in this model, we're using state is represented by restricted hierarchy sealed classes. We're using loading content error pattern, and we're using effects. You might commonly hear side effects as well, or events, but these are one-time actions. Now, the loading content error pattern, this is just more of a pattern. We didn't fall on this rigidly, or in fact, just using loading content, we do have an error, but our error state is that, that emitted effect that Dustin pointed out earlier, that toast message. And it's important for this because, if you rotate your device, you don't want to see your user doesn't want to see constantly a toast coming up that they don't have network service if it didn't work, or that you don't want to constantly launch a fragment if the user just keeps on going through rotation events. So now state data. State data is commonly applied to the content part of our state. This is our immutable data object in this presentation, at least. And it's not always going to be what you're binding to the view directly, but you can. This is a simplistic demonstration, so we are binding the state data directly. But the best way to think about this is when you get data from the model, you want that to be very simplified coming to the view. It should have no concept of how it's going to be displayed. You want that raw data, right? So when we take a look at our application, we have to think about what was being displayed there, right? We had a number which was initialized to 0. We had an edit text box which was initialized to an empty text. And then we had a button. We had add. When we talk about state with this, the two state components that were really being displayed was that number that was being added to, and then the edit text box as well. So then we have the action and actor. And these kind of sound similar, but they do work together. But they are different concepts. So what is an action? An action simply is an intent. It is a programmatic representation of what the user intends to do with the application, which is different than an actor. An actor is a programmatic representation of a user interaction with the application. So when Dustin was demoing our simple app, he was hitting the add button, right? Well, there's two different things that are actually occurring right there. There's the user interaction. It's the button, right? The user has no concept of the separation of these two, right? But there's really having to collect that interaction and then emitting and then getting that user's intent or expected intent rather from that action to the model. And so the actor produces an action from our XML view. And we'll go into this in a little bit of how this actually occurs. But the actor produces an action to be consumed by our view model. So talking about the view model, we'll start to get into the actual architectural components of this example, right? So what are the view model's responsibilities? It consumes an action, it processes model changes, and it emits a state, right? Now, when I say process model changes, it doesn't always have to do this. In our application, we're just adding a number. So we're doing that inside of the view model. But think about if we called out to an API and we wanted that API to add the number. We want to be extremely inefficient, whatever. We just want to implement a delay, or we want to talk to a database or something. We're going to process those. We're going to make a call to something. We're going to process those changes, and then we're going to emit a state later on. So this is the general interaction of the view model, or from the model to the view in our presentation here. So we have our view model simply emitting a state, which is going to be consumed by an activity.
So we know that was a lot of terms to go over. There will be a quiz. But right now we're going to jump into some code so that hopefully these concepts sink in a little bit more. So here we are inside of our view model. And you can see right at the top, we are declaring two values, state and effect. And again, these are going back to the state that we are consuming within our view model. Both of these are of type mutable live data, but notice that they're also values. That enforces that immutable state that we care for inside of this pattern. But they take in both mutable live data objects. And if you're unfamiliar with mutable live data, essentially an observer can subscribe to this mutable live data object, and whenever a new value is posted to that, that observer will be notified and they can process that. So both of those take in a type of MVI state. So we'll go ahead and click into that so you can see what the MVI state is doing. So this is that sealed class that we mentioned, which gives us that restricted hierarchy. So this is that, again, going back to the loading content error pattern that you just mentioned. So right at the top, we have our class of content, which takes in a type of MVI state data. And if we go into that, you can actually, so this is that data that we care to display to the user on our view. So the current value, that's that text field that was displayed up at the top. And then we have the toAdd value, which is our edit text field that will be entered in by the user. So hopping back out of that, you can see that we have our loading state, and then we have our an abstract class of effect, and then an object extending from that invalid number of error. So this could be loading content error, loading content effect, right? We display it here as an effect, but you can also picture here, a number of different errors depending on your use case for that view or model. So, depending on your interaction within that, you could assign different errors here that extend from this effect. And again, those will be that one-time occurrence, such as the toast message that we displayed whenever an invalid number was entered. All right, and so hopping back over to our view model, you can see that the value of effect is actually taking in that dot effect. So that just kind of shows you how we are assigning both of these to MVI state, but different types of state. And then, so we're going to skip over take action and handle add value action, because that's actually the interaction from the view back into our model. And again, that we're going to go into it, but that's that single entry point into our view model. Right now, all we care about is how we are updating from our model to back to our view. And so we're just going to hop down to this update function, which is actually handling that. So the update function is taking in a new state that was processed above, and based on that effect, or based on that state, we're going to publish that to those mutable live data objects that we had. So if it is an MVI state effect, we're going to assign that effect value to our new state. So, and you can see here that immediately after we assign it, we also set it to null. That's to account for that lifecycle change. So whenever our toast message was displayed, immediately assigning that to null will make sure it doesn't redisplay whenever you rotate the device. There are better ways to handle this. There are like other libraries that you can implement here, so you don't have to assign something to null in Kotlin, because that's weird. But we also have our loading state, so you can set there. And then we also have, if it's actually content that we care about that we want to display to the user, that's what we will set MVI state content. We will post that value up to our mutable live data object, and that will inform our activity that is observing this, or our view that's observing this, that, hey, we have a new value, and you need to process that. So stepping out of this, we're going to go back to a high-level overview of everything we just talked about. So, I know we just looked at code, but we again, we just want to continue to enforce all these concepts. So model changes, that comes into our view model and our model handler, which we kind of skipped over, which is going to call into our update state, which is going to post that value to our mutable live data object. And that new state can either be a state or an effect. And that's going to post to our live data object, which is going to update our activity through our observer, which is then going to process inside of our view, our XML view. So that's just kind of quickly high-level overview of view model to view interaction.
And just to quickly highlight something with this state change here is the way we're using sealed classes. We can essentially allow ourselves to have logic branches in both our view model in this case and our activity on both how something is emitted and how it's received. So the best way to think about this concept here, especially the way we're using sealed classes with loading content error pattern, is a tree trunk branching out. So you end up having your loading content error and even affect branches off of that. And each of these can have different branches off of those as well. It's best to keep it as simple as possible, but it helps process logic changes a little bit better, especially on the view side, where you might need a little bit more complex handling for errors.
And notice here in our comments as well, inside of this update function, we have that you can emit an analytic or some kind of log statement here inside of this. This is perfect because everything's going to have to filter through this update. So whatever state it is, whether it's an error, whether it's new content that you're posting, whether it's loading, all of that will have to pass through this update function. So this is a perfect place if you want to call back to home and say, hey, this is what state our app is in whenever we're entering it. This is an awesome place to implement that. So just wanted to highlight that.
Yeah, and each of these logic branches can have properties. So every individual state type can end up having its own identifier, its own analytics, its own information to process. So you can pass this onto your back end and have a very good idea of what state your application is in at any given point in time. So thanks, Dustin, for that. Let's talk about view responsibilities. It's really not that complex from a high-level overview. We consume a state, we transform state changes and bind those state changes to XML. We bind an actor, and we emit an action. So consuming a state, we just talked about the state. We're emitting it from the view model. We're going to be consuming it inside of the view. But transform state and changes and bind that to the XML, what does that mean? Like I mentioned before, we have state data, and we'll show you how we're directly binding that into the view. But if you have a more complex view state, that might not be the best case. In fact, it's probably better to split up how your data is handled in between layers in case there's an upstream change. Right, so we don't want our we don't want to change an API to reflect all the way down to the view layer, right? So we want to break these up. So a good way to do that is a transformer pattern. And think about this. So in our simple application, in our state data, we have two objects, right? We have two strings. One is one is a computed value, and one is a default value. Well, what if I wanted the user to enter a number between 0 and 10? How do you prompt the user to do that? Well, you're going to have to provide a minimum number and a maximum number, and then you're going to have to provide some kind of user experience so that they understand that's what they're supposed to be doing. Well, that's not the view model's responsibility. That's the view's responsibility. The view model shouldn't know what that string is that's going to be coming back. All it should really be aware of is what's that minimum value, what's that maximum value. It's up to the view to parse that string, format the numbers into the string, and maybe bold it or use the spannable to colorize your text or however you want to present that to the user. Then we bind the actor, and again, the actor is the programmatic representation of the user interaction with the device. It's that tapping the button. You could tap button A, you could tap button B, you could tap button C, but that means nothing unless we're relating that user's intent, which is emitting that action.
All right, so now we're going to hop into our XML view. And so the reason we're kind of approaching it this way is we're going to show you the view and then kind of hop back into the activity so we can show you how the binding works. But this is just a quick refresher of the UI of our application. Again, super simple. We have the text field at the top that's going to display that current value. We have an edit text field, which is where the user inputs the value, and then we have an add button. All right, so swapping over to the actual XML view up at the top is where we're actually setting up our data binding. So you can see over here, declaring two variables, actor and state. Actor is actually pointed to a type of MVI actor, so we're going to hop into that. So inside of our MVI actor, this is again going back to the actor and action relationship. Actor is taking in a higher order function of MVI action called emit. And inside of our function inside of our MVI actor, we have a function addClicked, which is going to be emitting that action of add value. So remember what Dan was talking about. The actor is the actual interaction that the user is having with the application. So them hitting the add button, which is going to call this function and emit an action because their intent was to add value. They wanted to add whatever that value they entered in to the current value. So that's kind of a high-level overview. And we'll actually hop into MVI action as well real quick so you can just see quickly what that's about. So this is just our, again, it's another sealed class, kind of giving us that restricted hierarchy. And we just have a class of add value inside of that. And you could imagine here inside of this actor, this could be essentially a contract for all the interactions that that one particular view could have. So if you had multiple back button implementations or multiply clicks or subtract clicked, all of those could be represented here. And they could be emitting different actions. So they could emit, MVI action.subtract value or MVI action.back value or go back. And what's neat about that is that multiple actors could essentially emit the same action potentially. So if you did have multiple ways to go back inside of your view, you could implement those inside of the actors pointing to the same action.
And so Dustin pointed out that emit is a higher order function. Well, what's sitting behind emit? Well, right now we're in the view, and we don't care, and we shouldn't care, right? This is a unidirectional pattern, and this enforces that unidirectional pattern here because emit can be a method inside of your activity, it could be in your fragment, it can be in a view model, which is actually what we're using to back this, but we don't care, and the view shouldn't either because we don't want to expose that extra logic to the view. And that is one of the downsides. You'll see in the MVVM pattern often is somebody putting a view model directly into XML and binding that. Well, that exposes behavior of the view model to the view, and that might not be preferable. And so this helps break that chain and makes this just a little bit more testable and more composed.
Yeah, and it goes back to that single responsibility that we're trying to enforce, that this pattern is trying to enforce. All right, so here we're back inside of our XML view. So the state just points to the MVI state data that we went over before, the current value and the to add value. All right, so down here we're actually going to show you how we're doing our data binding. So you see our text view just points to our state data and current value. Our edit text points to state data to add value. And then our button implementing on click function, which is actually just pointing to our actor.add click function inside of our MVI actor that we just talked about, which is going to pull that string that the user entered and pass it off to it. All right, so now we're going to hop into our activity to show you actually how we're setting our data binding and our observers against that. So at the top, you can see that we are declaring our binding to go up against our activity main XML. We're setting up our view model. We're declaring our actor. And notice where we are declaring our actor. And also notice that these are all values. But notice where we're declaring our value for MVI actor. We're passing in that higher order function here. So we're pointing it to view model take action. So this is actually what is going to be triggered anytime our MVI action is called. And then we set up the binding for our actor, and then we're going to call into observe data. All right, so inside of our function observe data, notice at the top we're declaring two values again: content handler, MVI content handler, and state observer. We'll come back to content handler first. So I'm going to dive into the observer. So again, the observer is going to be monitoring the mutable LiveData objects that we have and processing those as it sees that a value has been updated. And you can see down at the bottom that we are actually setting both the state and the effect content to that one observer. So if either of those are updated, they're going to be processed through this one observer. So again, it allows for that single entry point into our view to be processed. So we don't have to worry about it being implemented in multiple places. We can just process it all right here, and it enforces that unidirectional flow and that funnel that we care for because it allows us to process changes more predictably. And all right, so going into our actual observer, so if it's a null state, we're just going to go ahead and return. If it's not a loading state, we're just going to go ahead and just continue to hide the loading. But if it is a loading state, we'll show it down here in the when statement. Here's actually where the MVI state, that invalid number error, this is where we process that effect. So you can see here that this is where we are actually saying, display a toast of the you must enter a valid integer. So kind of like the content handler, which I know I haven't discussed, but you could have a separate error handler here if you had a lot of different errors that could be emitted from your view depending on what state the user puts it in. So you could pass whatever state came in off to that to handle it because you don't want to kind of bloat your when statement here with a lot of different effects or errors that could potentially happen. So it depends. It's your use case. But this is that one-time effect that we want to have. We want to display the toast. And then in our content, we just state that content. So if it's legitimate data that we care for, that we want to display to the user in some form or fashion, we will pass it off to our content handler. So we're going to hop into that real quick. So this is, because we have such a simple app, we're not really doing a whole lot here. We're just essentially just notifying that there was a change. But if you did have a more complex application, this is where you could apply things like translation or bolding the text or italicizing it or doing some kind of processing on it inside of the view, because the view model doesn't necessarily care like what the view looks like or what it looks like when it's displayed to the user. It just cares what those values are. And I know some of you might just be saying, well, why don't you just put this back in the activity? It's pretty simple. And the reason for that is because extrapolating it out allows for easier testing, because you don't want to just throw everything in your activity, because then you have to worry about how are you going to be able to test that reliably, because you're going to have to use things like PowerMock or what have you. So in this instance, we're able to essentially test this without having to worry about the activity or the fragment use cases there.
And as Dustin mentioned here, the content handler is not a hard requirement of MVI, but it helps here, because especially as you start to filter more states or actions, you want to use a handler pattern to kind of break out the responsibility of handling that action or that state. And as he mentioned, this is where you might apply a transform, but you might likewise put together an error message for the user to see. And again, this is a bit more testable. It's a bit more broken out and more towards the single responsibility principle.
All right, so this is just going back over what we just talked about. So we'll run our activity. We had our on create that we set up our data binding for both our actor and our state data to tie into our XML view. And then inside of our, also inside of our activity, we declared our MVI actor, which is going to be anytime the user, again, pushes that add button or interacts with the application somehow, that's going to emit an action, as you can see here, and that's passing into our view model and into our take action, which is what we're about to go into next. That's the area that we kind of glossed over before. All right, so hopping back to our view model. Hopping back to our view model.
I don't know, my computer just ate its lunch. We are, for some reason, not going to the... We'll find our view model. There we go.
Yeah, there we go. All right, so this is that take action function. So that is a higher order function that we were passing in to our actor when we initialized it. And so all of our actions that are being emitted by our actor will be passing through this. Again, that single entry point, unidirectional flow. This is our view talking back into our model and our view model. This is just kind of reinforcing that flow that we have here. And so if it is an add value action, then we're actually going to pass that off to our handle add value action function. All right, and here we are essentially processing whatever string that user entered. So if it was a null string, then we are going to say, hey, this is an invalid number error. And that's what we are going to set the new state as. Else, if it is a legitimate value that the user entered, then we will go ahead and process that value. So we will add the current value to the new value. We have kind of our example of a reducer here to create that new state data and copy that. And then we're going to set the new MVI state to content with our new data. And then, again, kind of calling back to what we went over when we first showed the view model. That's what we're going to call the update new state next. And this is what we went over earlier. So this is going to process whatever that new state is. If it's in effect, go ahead and set that and set it to null, it's loading. But regardless, this value is going to, again, post back to our activity. So this kind of brings us back full circle to what we just discussed. And here is the full MVI implementation. So what's really nice about this is you can clearly see the distinction between the model, the view, our intent. You can see just with the flow how it is all in unidirection. And the single entry points as well that are being set up inside of both of our model and our view. So we'll walk over it again, but so our MVI actor called our MVI action, which hit our take action inside of our view model, which called our action handler. That action handler, which was that two-handle add value action, then updated our model in some form or fashion, which called into our model change, our model handler, which then updated our state. That state was either, it was a legitimate value that they passed in, or it was a fake, or it was a null integer. And then we, whatever the case, we pass that off to our mutable LiveData object, which our activity is going to see was updated. That will call back into our activity, which will update our XML view, and then the cycle just kind of starts over. The user interacts with the application in some form or fashion. It's going to emit another action. But so this is just kind of to give you that overview of everything that we just went over. And again, some of the key takeaways from all of this is here alone you can see the clear swim lanes between the model and the view. And what's nice is say you have a designer come to you, like, hey, this is the new feature, the new view that we want to implement into our application. And they just kind of drop that on your table. You can clearly set up like what contracts is that view, or what interaction is that view going to need to handle. And you can just design your view, figure all of that out. And if you're, depending on if you're a team environment or a solo environment, you can decide like which portions of this you want to tackle first. So if you want to focus on the view, you can knock that out. You can set up your contract for what actors are you going to have on that screen, what actions are they going to emit. And then, if you do have a separate team working in conjunction with you, they can be focusing on the model portion, the view model portion of that interaction. So they can be working kind of simultaneously towards this one feature, and you can have a pretty good success rate with that because you're establishing pretty clear contracts with this pattern and architecture.
And just to drive home some of the points that Dustin made here, what I really like about this pattern is you have two main contracts here. You have the state and you have the action. As soon as you get your designs or the concept that you're looking at, you can take a look at that view and have an idea of what type of state and what type of action, or what type of state creates that view, and what type of user interaction will be emitted out of that view. So it becomes very easy to start to implement this on both sides. And if you look at this actually breaks down into 4 different components. So you can be working on these 4 different components in parallel. And these components are, in this case, the activity. Then we have our XML view. We have that lower half of our view model here. And then we have our view model itself. All of these are separated. So you can work on this if you have a team. You can have a member of the team working on each component. You can have different teams working on different components. You can just leave one off and come back to it, which makes this really easy to structure and decompose and maintain.
All right, so in conclusion, we're going to harp on those 3 points that we've been harping on this whole time. So again, one of the great things about this, the unidirectional data flow, that just makes it so, kind of tying into the single immutable state as well, it makes it so you can process things, as you want. And if it gets into a weird state, you don't have to deal with that. You can just, ignore it and just only worry about the states that you care about coming in and processing those. And that also sets up that single responsibility that we care about. Single immutable state just helps us with that predictability of the different states that our application can get in. Then that single entry and exit point just helps us define those clear contracts between what's going into our model and what's going into our view.
Right. And that's all awesome, but I'm going to put some caveats here, right? So this is a simplified example. The title of this was Simple MVI. So I like to call this presentation not production ready, right? So there are some components of this. This is just to get you off the ground with the MVI pattern. You're still going to want to implement your own error handling, your own scoping to some of these functions. You might want to break out how we are using the LiveData functions, and those are actually accessible within the view model, and just expose the update state that we have. You definitely don't want to publicly expose your mutable LiveData like we have. There's a few different things in this pattern that are just to simplify for presentation. We didn't want to have 200 lines of code. We wanted to present something that's very clean, concise, simple to understand. That said, this pattern in general, using MVI or using LiveData for your pattern might not be the best either. And it really just depends on what your view is composed of and how much interaction the user is going to have for it. It's very common to see coroutines and RX, Java, Android, Kotlin, whatever, used in the MVI pattern. But they're not absolutely necessary, but they do have their purposes. Think back pressure that you can implement through Flowable and RX or Flow and coroutines. So those are obviously very helpful if you're having multiple interactions with a view, think just a game or something to that degree. And then that said, with any architecture pattern, this is not a silver bullet. So you shouldn't try to take your project and fit it towards this pattern. Take this pattern and see, how can this work into my project? Is this the right pattern? And you don't even have to have a single architectural pattern per project. You can have modules, you can have subcomponents that are in different patterns to do this. In reality, like the app that we demonstrated here, I would probably host it all in the same activity. It's a very simple application. If that's all it was going to do is have an add button, that's what I would do, right? Not do an MVI example, but this is something that you can see can kind of help if you have a simplistic user experience to break those components apart to make it something easily testable that can be worked on in unison. So with that said, before we get into questions here, I will be posting a blog post on this in the next couple of days, so make sure to follow me and Dustin on Twitter if you want to get an update on that. At the very bottom of the slide, we have the branch that this is on in the GitLab. The master branch actually has a little bit more production-friendly implementation, a little bit more production-friendly implementation of this. I just wanted to exclude it because I included an external library, and I wanted to keep this as vanilla Android Studio experience as I possibly could. In fact, the only modification we made to Gradle from creating a new project was enabling data binding within that Gradle file to make this possible. So with that said, any questions? We have 3 minutes, I think.
I have one little odd detail view that deals with the Joe White, I had one little odd detail view for people new to this process. When you look at effect, and you set the effect to a particular value and then set it to null, it depends on you knowing that there's side effects that occur from setting a particular value someplace,
Right.
which can be kind of opaque. How many people do you find looking at that and say, well, this does nothing, let me throw it away from me?
Right. That's a possibility. So, so that is one of the key components that I would change for this for production. I would not manually set that value there. There are libraries. There's primarily Live Event that handles this in a little bit more of a contained fashion, where it only emits once per observer, and that handles the state. This was just so I didn't have to add on. One over here. Yeah. Sorry, the microphone's for me, not everybody else. I can't hear.
Do you have any personal experience or opinions on Redux and the comparison between the MVI pattern? Is there any silver bullet point for differentiating between the two?
Your use case? I mean, yeah. I mean, it's a cop-out answer. I know it's just everybody's situation is different.
It depends.
Yes. I think somebody was writing a blog post on that. Just